Welcome back. This is Lesson 2 in Module 2, Learning the Language of Design. Today we'll be talking about identifying Norman's design concepts on the web. We'll briefly review the principles of good design, and then we'll get right into looking at some websites. I encourage you after this lecture to go back and look at some sites on your own. Look and see how these principles were or were not applied on the websites you're looking at. The principles of good design is to ensure that the user can figure out what to do and can tell what's going on. On the web, this means that all users, no matter where they are, what device they're using, whether that's an iPad, an iPhone, a web browser, or a screen reader, that they can effectively use and interact and find the information that they're looking for. Today, we'll be applying Norman's design concepts to the web. Specifically, we'll be looking at these 5 areas: affordance, visibility, conceptual model, constraints, mappings, and feedback. Every product should be both usable and understandable for all users, including users with disabilities. We've talked a lot about everyday objects, and now I'd like us to shift to talk about how these same principles can be applied to the web. Take a moment and think about a website that you've visited recently. How do each of these principles apply to the web? There are 7 principles for user-centered design. They are: 1. Use both knowledge in the world and knowledge in the head. This is all about creating a good conceptual model to help users understand the website. For example, an expanding menu on a website mimics the known structure for storing files on a computer. Using elements that users already know will shorten the time it takes to learn the system and help all users, especially those with disabilities. 2. Simplify the structure of tasks. This is all about minimizing the amount of planning, problem solving, or attention required. Keep in mind the limits of information that users can retain. And note that users with learning disabilities or other cognitive impairments will have difficulty understanding complex tasks and will get easily distracted. Providing mental aids, visible feedback, and simplifying tasks will go a long way to improving the usability and understandability of the website. 3. Make things visible. Users need to know what actions they can perform and the results of these actions. The system state should be readily available. The thing to keep in mind here is that we're not just talking about being able to see visually, but that these should be apparent to a user who cannot see the screen as well. A blind user, for example, uses a screen reader that produces an auditory output of the screen. For them, they need to know, just like a user who can see the screen, what is going on, get the appropriate feedback. Number 4, get the mappings right. Make sure that the user can determine the relationships. Again, this should be known both visual and non-visual users. 5. Exploit the power of constraints so that the user feels as if there's only one possibility to do the right thing. 6. Design for error. Users with disabilities often make more mistakes. Assume that errors will be made, plan for it, and handle those errors when it occurs. Make sure that the error messages are apparent to both sighted and non-sighted users. And number 7, when all else fails, standardize the actions, outcomes, layouts, and displays. Use web conventions when designing sites and make the actions work in the same way. This helps all users, but especially those with disabilities. So now let's take a look at several different examples. We're going to go through some sites that have done things fairly well and are often used as good examples of good user-centered design. And then we'll also look at some sites that are not doing things so well. Amazon is a good example of a site that does most things right. When you go to Amazon's website, you don't have to think. Everything you need is right there, and it's streamlined so that all you need to think about is purchasing the product. You can interact with the same data in 15 different ways, whether that be on your iPad, your desktop, a particular time, previous searches. They get everything right. When I come to Amazon, I know what I looked at the last time I was there. And they've got other products that I might be interested in. Everything is tailored directly to the user. The constraints are correct. There's focus on the only object you want to purchase. For example, when I'm on the product page, focus is only on that product and actually purchasing that product. All of the information that I may want in order to make my decision is there. I know how other customers have rated this. I know that I can get this product using my Prime membership so that I can get free shipping. And I've got information about all of the features. It's the type of experience that the user wants. But even Amazon is not perfect. Amazon's done a lot of things right on their site, but if we look at this from a universal design perspective, one that includes all users, there's some improvements that Amazon can make on their website. For example, the checkboxes that you're seeing on the screen, visually they look like checkboxes, so we know we can check or uncheck the options. But for a user with a visual impairment, these are not defined as checkboxes. So if a user who's using a screen reader comes to this, they're not going to hear anything. It's not going to be defined as a checklist. If you look at the underlying code, you can see why. This is defined using CSS sprites, and it's an italics element in HTML. Well, if something's defined semantically as an italics, it's going to be known to a screen reader user as italics. And that role, that it is a checkbox, is not known. So it's really important that the visual affordances, the things that we see on the screen, are also translated at the code level, and that the most appropriate HTML elements are used so that all the page elements can be perceived. Check out the mouse pointer on this site. When you first get to the site, you're not thinking about the content, but you're really trying to figure out what's this cow thing that is moving when I move my mouse. Everything that you do now, you need to think about. Where do you position the cow's head in order to select an item? Another issue is that on this site, there is no feedback given to users who are using a keyboard. So, people who are relying on a keyboard will use the tab key and tap from element to element. The problem here is that there's no visual indicator, no feedback to the user on where they are on the screen. So they won't know where they can go or what they can select. Or, if they do press enter, where they're going to go. Also, the motion on this screen, there's those arrows at the bottom that are going into the crazy cow building, can be very distracting. And it's not apparent that you can actually do anything in this building. So they've had to build in these extra visual cues or instructions in order to help users understand what they can do here. If they had done some simple interactions, things that were known, it would be apparent to all users of what they could do. For example, if you could see the door and the door was open, you would know that you could maybe interact with that. But in this case, we don't even see the door and we don't know that we can enter it. What options can you do here? Where's the main menu? Did you guess the image on the left? This is a non-standard menu system. It does not map to any conceptual model and it would require users, when they first get to it, to explore the site, figure out what is clickable, what's not clickable. If I hover over one of those plus signs in the image, what does it do? What's associated with it? Well, if you look at the bottom of the screen, you can see that the one that I've currently hovered over is recruitment. But that is quite a distance away from the actual object that I'm hovering over. It may not be apparent to all users who are coming to the page. If this site had used a typical menu system, users would immediately know how to find information on the site. What is this site and what can you do here? For me, it was impossible to tell what actions were possible. Do you know how to get to the Twitter feed? Again, on this site, the conceptual model is broken. We don't know how to figure out or what can be done easily without having to explore the site. Another issue with this site is that it's completely blocked access for those with mobility impairments who rely on the keyboard for input, and those who are blind will not be able to access any of this content at all. And this was due to the fact that it was Flash and how it was produced. So it's important as we look at sites and think about how users are going to interact with them, that we make sure that all users, including users with disabilities, can access.